In 1998, we figured out how the universe ends. Dark energy was pushing everything apart, faster and faster, and it was never going to stop. So the universe would die the coldest death imaginable. The stars would burn out, the galaxies would race away from each other until each one was utterly alone in an ocean of black. And then, slowly, over spans of time so long they make the word eternity sound impatient, everything would simply fade. Cold, dark, empty, forever. We put it in the textbooks. We taught it to students. A whole generation of us made our quiet peace with it. And then, over the last 18 months or so, the largest three-dimensional map of the cosmos ever made looked at that answer and gently suggested it might be wrong. Not refined, not adjusted at the third decimal place. Wrong. As one of the physicists working on it put it, even 2 years ago, the alternative scenario was simply out of the question.
Now, I want to be honest with you about where this video is going, because it is not where you think it's going. I didn't start here. I started somewhere much more embarrassing. I started with a child's question. The kind of question a 6-year-old asks, and an adult learns to stop asking because it makes you feel stupid. What is at the edge of the universe? If I built a ship, and I pointed it in one direction, and I flew straight, forever, what would I finally hit? A wall? A door? A locked gate with a sign that says, "You have reached the end, please turn around"? Or nothing at all? And if nothing, what does nothing even look like from the inside? I spent weeks chasing that question. I chased it through black holes, through hidden dimensions, through the death of time itself. And I want to tell you something strange. Every single path I took led to a dead end. Every one. But the dead ends were not failures. Each one was telling me the same thing, in a slightly different voice. And what they were telling me was this. The question was broken. I was broken. Every map of reality that human beings have ever drawn, including the one we are so proud of right now, in 2026, with all our satellites and supercomputers, is a mask. A painted face we pull over the front of something we cannot see. And in 2025, for the first time in my life, I think I watched the mask start to slip. This is going to get strange. Stay with me. So let me tell you about the book, because almost everything I'm about to say grew out of one book, and I owe you that honesty. The book is called Cosmology, the Science of the Universe. It was written by a man named Edward Harrison, a British-born astronomer who spent most of his career in the United States, and it is, on the surface, a university textbook. Which means I should warn you, parts of it read like a university textbook. There are stretches where Harrison the working scientist takes over, and you need a strong coffee and a pad of paper. I don't pretend I understood all of it. Some of the equations went straight over my head, and I'm not going to insult you by pretending otherwise. But here is what makes Harrison different, and why I keep coming back to him. Most cosmology books are afraid of philosophy. They treat it like a contaminant. Harrison runs toward it. He ends chapters not with a tidy summary, but with a question aimed straight at you, the reader. And he had one central idea, one image, that I have not been able to get out of my head since I first read it. Harrison says that every civilization that has ever existed has painted a mask, a picture of the cosmos. The Babylonians had theirs. The Greeks had theirs. The medieval Christians had a gorgeous layered one, with crystal spheres and angels turning the heavens like clockwork. And every single civilization made the same mistake. They mistook their mask for the real face underneath. He even gives us 2 words to keep them straight. There is the universe, lowercase. That's the model, the story we tell, the map. And there is the universe, capital U, the actual thing, whatever it really is, which no human being has ever seen directly or ever will. And here's the part that should make the hair on your arm stand up. Harrison says, flatly, that our descendants will look at our universe, our dark matter, our inflation, our elegant expanding spacetime, with exactly the same gentle, pitying smile that we give to the medieval drawing of angels turning crystal spheres. We laugh at their mask. They will laugh at ours. I didn't believe him. Then 2025 happened. So let me show you the cracks. They're spreading right now, in real time, while you and I are having this conversation. For about a quarter of a century, the standard model of cosmology had a name, and it was nearly perfect. Roughly 70% of everything is dark energy, the stuff pushing the universe apart. About 25% is dark matter, the invisible scaffolding holding galaxies together. And the thin sliver left over, about 5%, is everything else. Every star, every planet, every atom in your body, every person you have ever loved. 5%. We are the rounding error. And inside that model, dark energy was assumed to be a constant. The same yesterday, today, and 10 billion years from now. A steady, unchanging pressure baked into empty space itself. Einstein had a symbol for it. It was the thing that, if it stayed constant, guaranteed the cold and lonely death I described at the start. Then came DESI, the Dark Energy Spectroscopic Instrument, a machine sitting on a mountain in Arizona that does something almost unimaginable. It measures the precise distances to millions of galaxies, building the most detailed 3-dimensional map of the cosmos that has ever existed. And in its second data release, in 2025, when they combined that map with the cosmic microwave background and with exploding stars called supernovae, the numbers came back off. Dark energy did not look constant. It looked like it was changing, evolving. And here is the phrase I want you to hold on to, because you are going to hear it again and again as we go. This puts our standard model in doubt. Depending on which set of supernovae you fold in, the evidence against the simple constant climbed to around 4 sigma. In physics, that is not proof. 5 sigma is the gold standard. But 4 sigma is the sound of a floorboard creaking under your foot in a house you thought was solid. And it isn't alone. Up above, the James Webb Space Telescope keeps finding galaxies in the very early universe that, by our model, should not exist yet. Too big, too mature, too soon. As recently as 2026, astronomers reported an enormous early galaxy that wasn't even rotating the way the rules say it should. And every time, the careful, sober language of the press release does the same thing. It says, in effect, "This challenges our understanding." Notice the phrase that keeps repeating. This puts our model in doubt. Pay attention to it, because it is going to turn out to be the truest sentence in this entire video. Alright, let me actually try to fly to the edge. Let me take the child's question seriously and build the ship. Here is your ship. It has one feature. It can accelerate at 1g forever. 1g, meaning you'd feel exactly the gravity you feel right now, sitting wherever you're sitting. Comfortable. Earth normal. You'd never feel like you were straining. You'd just feel weight, the way you always have. So you light the engines and you go straight up, away from everything. In the first couple of hours, you pass the moon. Within a week, you're crossing the orbit of Saturn. Within a year of this gentle, comfortable 1G push, you are moving at a speed that starts to bend the rules. Because the longer you accelerate, the closer you creep to the speed of light. And the closer you creep to the speed of light, the stranger time becomes. This is not science fiction. This is the most thoroughly tested theory in the history of physics. Time, for you, slows down. Not from your point of view. To you, your watch ticks normally, your heart beats normally. But the universe outside begins to fast forward, and distances start to shrink. The galaxy that was 100,000 light years across begins, from your seat, to look thinner, compressed, closer. Let me give you something real to anchor this, because it sounds like a fairy tale. In 1991, in the desert in Utah, a detector caught a single subatomic particle moving so fast that physicists nicknamed it the "Oh my God" particle. 1 proton, carrying the energy of a fast baseball. Now, for us, watching from the outside, that particle would take millions of years to cross the gulf between galaxies. But ride along with it. Sit in its frame of reference. In a journey of 2.5 million light years, the distance to the Andromeda Galaxy passes in under 5 minutes. Less time than it takes to make a cup of tea. So you, in your ship, you've got that on your side. You could, in principle, cross unthinkable distances within a single human lifetime, because time itself folds up to let you through. Here's where it gets strange. You will still never reach the edge. And not because there's a wall, because of something far worse. Remember dark energy, the stuff pushing the universe apart? While you've been flying, space itself has been stretching. And far enough away, that stretching adds up until distant space is receding from you faster than light can cross it.
There's a line out there, call it the horizon, and once a galaxy slips past it, no signal you send, no ship you launch, no light you shine can ever catch up. The road home closes behind you. Cross something like 8 billion light years, and you can never come back, because the space between you and home is unspooling faster than you could ever fly across it. Think about what that means. Fly far enough, long enough, and your ship becomes the only place in the entire observable universe where time still means what it used to. Everything you knew has receded into a glow on a horizon that keeps retreating, no matter how hard you chase it. You cannot reach the edge. The edge runs away from you faster than light. That's dead end number 1. Hold the image of that lonely ship. We come back to it. Maybe, you might be thinking, maybe the problem is the running. Maybe I shouldn't chase the edge. Maybe I should just ask what shape the edge is. This is an old question, older than telescopes, older than the church. About 24 centuries ago, a Greek philosopher named Archytas posed it with brutal simplicity. Walk to the very edge of the universe, he said. Now throw a spear. What happens? Either the spear flies onward, in which case that wasn't the edge, was it? Because there's space beyond it for the spear to fly into. Or something stops it. But if something stops it, then there's something on the other side of the edge doing the stopping. Either way, there is more universe past the edge you just found. So there can't be an edge. The universe must be infinite. For 2,000 years, that argument felt airtight. And it is wrong. Beautifully, instructively wrong.
And the reason it's wrong is a story I love, because it's a story about fear. In the early 1800s, the greatest mathematician alive was a German named Carl Friedrich Gauss. And Gauss had figured out something that frightened him. He had worked out that space did not have to obey the geometry we all learned in school. The geometry where parallel lines never meet, and the angles of a triangle add up to exactly 180 degrees. He realized space could curve, and on a curved surface, those rules quietly break. Draw a big enough triangle on the surface of the Earth, and its angles add up to more than 180 degrees. The page lies. The page was always flat, and the world is not. Here's the part that gets me. The legend says Gauss, while running a land survey, measured the angles of an enormous triangle between 3 mountain peaks to check, in secret, whether the space we live in was curved. Historians argue about whether he really meant it as a test of the cosmos, or was just doing his day job. But what nobody argues about is this. Gauss sat on the deeper idea for years and refused to publish. He was terrified. Not of being wrong, terrified of being thought a madman. He had glimpsed something true so far ahead of its time that saying it out loud felt like social suicide. Sit with that for a second. The terror of being right too early. Because once you accept that space can curve, Archytas' spear loses its power. Imagine an ant walking in a straight line on the surface of a basketball. It never hits an edge. It never gets stopped. And yet, the surface is finite. It's not infinite. It just has no boundary. Walk straight long enough, and you arrive back where you started, having never turned. The universe could be exactly like that. Finite, with no edge, no wall, no spear-stopping barrier, because it curves back on itself. Or it could be flat, but folded, like one of those old arcade games where flying off the right side of the screen brings you back on the left. Fly straight long enough, and you come home, from behind. So we measured it. We measured the geometry of the universe with exquisite care. And the answer came back. Flat. Flat to within about 1/4%. Which sounds like an answer. It isn't. Because measuring it flat to that precision doesn't tell you it's flat. It only tells you that if the universe does curve, it's so vast that the curve is too gentle for us to detect. Meaning the whole thing is at least hundreds of times bigger than everything we can possibly see. The wall, if there is one, is so far past our horizon that asking about it is like an ant on that basketball trying to measure the curve of the planet it lives on. We didn't find the shape of the edge. We found the size of our own blindness. Dead end number 2. Okay, new plan. If I can't reach the edge and I can't see its shape, maybe I'm thinking about this wrong. Maybe the edge isn't out in space. Maybe it's in time. Maybe the real edge of the universe is its ending. And this is the part of the story where I have to stop and tell you that I had to rewrite this entire section. Because between when I started this video and now, the ending of the universe changed. Let me explain. The version I grew up with, the version baked into that 1998 discovery, was called the Big Rip in its most dramatic form. The idea was that if dark energy didn't just stay constant, but actually grew stronger over time, it would eventually win against everything. First, it would tear the galaxy clusters apart, then individual galaxies. Then it would rip our solar system loose. Then it would shred planets. Then atoms. And in the final instant, it would tear apart the fabric of space-time itself. Reality unstitched. Terrifying.
cinematic. And, based on the newest data, possibly off the table. Because remember what DESI found in 2025. Dark energy doesn't look like it's growing, it looks like it's weakening. And if dark energy is fading rather than strengthening, then the Big Rip's engine sputters and dies. The thing that was going to shred the cosmos is running out of fuel. So what takes its place? The oldest ending of all. The one we thought we'd buried decades ago. The Big Crunch. In 2025, a physicist named Henry Tye at Cornell, an emeritus professor, a serious man, not someone chasing headlines, published a paper with colleagues with the almost unbearable title, The Lifespan of Our Universe. And working from this new data, he calculated something specific, not vague, specific. He found that the universe will keep expanding for roughly another 11 billion years, reach its maximum size, and then stop, and then reverse, and then fall back in on itself, contracting faster than it ever expanded, snapping back in his own image, like a stretched rubber band released, collapsing in the end to a single point. And he gave it a total lifespan. About 33 billion years from beginning to end. The universe is around 13.8 billion years old right now, which means, and I had to read this twice, we are already more than a third of the way through the entire life of everything that exists. We're past the opening act. As Tye put it, for the last 20 years, people believed the cosmological constant was positive, and the universe would expand forever. The new data, he says, seems to indicate it's negative, and that the universe will end in a big crunch. I want you to hold the two endings side by side. The big freeze, cold, dark, infinite, lonely. And the big crunch, a fiery collapse, everything that exists falling back into a single burning point. Those are not small differences. That is the difference between forever and an ending. That is the difference between dispersal and reunion. And the fate of literally everything, every star, every atom, you, me, the whole story, flipped from one to the other in the span of about a single year. Not 1,000 years of careful progress. 1 year.
The mask slipped, and I watched it happen. And almost nobody outside of cosmology noticed. And honestly, if a sentence like that gives you the same vertigo it gave me, the feeling that the floor you trusted just shifted a few inches, then sticking around here is probably a good idea. Because where we're going next is even stranger than this. This channel only exists because enough people decided that this particular kind of vertigo is worth chasing. So if it's your kind of rabbit hole too, come along. There's a lot more down here. Now, you might stop me right here. You might say, hang on, you just told me the data is only at 4 sigma. You told me Tye himself admits the parameters are uncertain. You told me a different team in late 2025 looked at the same supernovae, argued they'd been mismeasured because of an age bias, and concluded the expansion is slowing for slightly different reasons. So which is it? Big freeze, big rip, or big crunch? And you'd be right to push. Here's my honest answer. I don't know. Nobody knows. That is precisely the point. The point was never which ending wins. The point is that the destiny of the entire cosmos is, right now, an open question that lurched in a brand new direction inside the last 12 months. And it could lurch again next year. We are watching a civilization repaint its mask in real time. And you and I are alive for the brushstroke. That's dead end number 3. Not because we hit a wall, but because you'd be torn apart or frozen or crushed long before you ever reached an edge to touch. The ending of the universe is not a place you can visit. So I went looking for a back door. If I can't get out the front, out through space, maybe there's a side exit, out through a dimension I can't see. This is where the math goes from strange to genuinely dizzying. There's a family of ideas, often grouped under the name M-theory, that says the 3 dimensions of space we experience are not the whole story. That reality might have 10 or 11 dimensions, and that the extra ones are curled up impossibly small, or hidden in a way our senses simply cannot register. In some versions, our entire universe is a kind of membrane. Physicists actually call it a brain, floating in a higher dimensional space. And there could be other brains, other universes, right next to ours, closer than the far side of the room, just offset, in a direction we have no name for and no organ to perceive. I know how that sounds. Sounds like nonsense. Bear with me, because there's a way to feel it. Imagine a being that lives entirely on the surface of a sheet of paper, perfectly flat. It has length, it has width, it has no concept whatsoever of up. Now you, a 3-dimensional creature, reach down and press your fingertip against the paper. What does the flat being see? Not a finger. It can't see a finger. Finger is a word in a direction it doesn't have. It sees a circle appear out of nowhere, grow, and then vanish. Magic. A miracle. An intrusion from a dimension it can't even imagine. That flat being is us. And here's the eerie thing. It's not just a metaphor. There have been experiments where people were asked to learn to navigate a 4-dimensional maze in virtual reality with the extra dimension mapped onto cues their brain could learn. And slowly, clumsily, some of them got better at it. The human brain, it turns out, can be trained to develop a crude intuition for a direction it was never built to sense. We are not as locked in as we feel. But, and here's the cruel part, the reason this is a dead end. Even if all of this is true, even if there are other universes a hair's breadth away in a hidden dimension, the door only opens one way. In these models, the only thing that can leak between brains is gravity. Things can fall in to us. We cannot climb out. We could be surrounded, pressed in on all sides by entire other cosmoses, and we would never feel the wall, never find the door, never get through. The neighbors exist. The house has no exit. Dead end number 4. At this point, I was genuinely stuck. 4 routes, 4 dead ends. And then I picked up a different book, and it changed the question entirely. The book is Black Holes and Time Warps by Kip Thorne. And Thorne is not some popularizer. He's a Nobel laureate. He was the science advisor on Interstellar. He is one of the people who actually built the modern understanding of what black holes are. And what he showed me is that I've been asking, where is the edge? When the universe has been quietly answering, the edge is not a where. The edge is a when. At the center of a black hole is something called a singularity. And the singularity is not a place. It is, as best we can tell, the actual end of spacetime. The point where the road of time itself simply stops.
There is no after. Not in the sense that nothing happens after, in the sense that after is a word that no longer has any meaning there. It's the closest thing to a true edge that physics has ever found. And you could, in principle, go look at it. Here's a thought experiment that I find almost unbearably beautiful. Take the very largest kind of black hole, a supermassive one, 10 billion times the mass of our Sun, the kind that sits at the heart of giant galaxies. Counterintuitively, the bigger the black hole, the gentler the crossing. For one that large, you could fall straight through the event horizon, the point of no return, and feel absolutely nothing. No alarm, no tearing. You wouldn't even know you'd crossed the line of no return. And then you would have something like 20 hours. 20 hours of perfectly ordinary feeling existence, falling, knowing that every direction you could possibly move now leads to the same place. The end of time. There is no longer a direction called away. The singularity is in your future the way tomorrow is in your future, unavoidable no matter which way you turn. And here is what Thorne describes happening at the very end. And this is the most haunting physics I have ever read. As you approach the singularity, the laws of the ordinary world break down and a deeper layer takes over, something we only half understand, called quantum gravity. And down there, space and time stop being a smooth, woven fabric. They come apart. Time gets ripped away from space. The neat distinction between before and after dissolves. And space itself stops having a definite shape. It becomes a kind of churning, probabilistic foam, here and not here, this shape and that shape, all at once. Thorne reaches for an image to describe it, and it's perfect. He says, imagine space-time is a piece of waterlogged wood. The water soaked into it is time, and the singularity is a fire. As you fall in, the fire boils the water, time, clean out of the wood, and what's left, raw space, with nothing holding it together, crumbles into ash. That is the closest thing to an edge that exists in this universe. And look at what it is. It isn't a wall. It isn't a door. It is the place where the very categories we've been using to ask the question, where, when, here, there, edge, quietly stop working. We went looking for the boundary of reality, and we found the boundary of our questions. And that is when the whole thing turned over for me. That's when I realized I'd been making a mistake from the very first second. Let me say what the mistake was. The whole time, on every one of those 4 routes, I'd been imagining myself as a tourist. Someone standing outside the universe, peering in, trying to walk to its fence. And that picture, the picture of me as a separate observer looking at the cosmos from somewhere outside it, is not just hard to achieve. It's impossible, in principle. And it's impossible for a reason that has nothing to do with rockets or telescopes. Go back to Harrison, the man who started all of this. He points out something that I think is the single deepest sentence in his whole book. Cosmology, he says, is the only science that tries to take every single piece and assemble them into one complete picture. One map of absolutely everything. And it is therefore the only science that cannot find anywhere to stand the person who is drawing the map. Think about that. A geologist studies rocks and stands outside the rocks. A biologist studies cells and stands outside the cells. But a cosmologist is trying to draw a complete picture of everything that exists. And the cosmologist is part of everything that exists. You cannot step outside the universe to sketch it, because there is no outside. The Mapmaker is inside the map. There's an image that captures this better than any equation. The artist M.C. Escher once drew a self-portrait, his own hand holding up a polished, mirrored sphere. And in the sphere, you see his face, his room reflected. But look closer. In the reflection, he is holding the sphere. And in that reflected sphere, there would be another reflection of him holding it. Forever, down and down, smaller and smaller. The artist drawing the world that contains the artist drawing the world that contains the artist. There is no first frame. There is no outside the picture. That is cosmology. We are conscious beings studying a universe, and that universe contains conscious beings studying a universe which contains us. We cannot get out. And it goes deeper still, because here is a thing that I find genuinely staggering. There is no physical experiment, none, not now, not ever, even in principle, that can detect whether something is conscious.
I am certain that you are conscious, that there is something it is like to be you, sitting there listening to my voice. But I cannot measure it. There is no instrument that registers it. The one thing I am most certain of in the entire universe, that I am here, that I am aware, is the one thing that leaves no trace on any of our maps. So the map of everything physical has a hole in it, and the hole is shaped exactly like the person holding the map. That's the answer. That's the edge I was chasing. The edge of the universe turns out to be the edge of the knower. We never wanted geography. We wanted to find the boundary of reality, and reality kept handing us back the boundary of ourselves. A Greek named Protagoras said it 24 centuries ago, long before any of our machines, and got laughed at, and was mostly right. Man, he said, is the measure of all things. This is the part where, if you're 40-something and you're watching this at midnight, you sit up in bed.
And you'd think that would be the end. You'd think, all right, fine. We can't get outside the universe, we can't see ourselves, but at least the universe itself is solid. At least space-time, the stage, the arena, the fabric we all move through, at least that is real and fundamental and the bedrock under everything. No, let me rephrase that. I wish that were the end. It isn't. Because the most fundamental feeling thing of all, the space you're sitting in, the time you're living through, the absolute floor beneath physics, is now the leading candidate for the next mask we tear off. There is a physicist named Nima Arkani Hamed, and he's been chasing something that sounds like heresy. He has a phrase he's fond of: space-time is doomed. And he doesn't mean it's going to be destroyed. He means it was never the bottom layer to begin with. Here's the idea as best a curious layperson like me can hold it. When physicists calculate what happens when particles collide, they normally picture little particles moving through space over time, bumping into each other. Locality, the rule that things only affect what's right next to them. And the calculations are monstrous. Pages and pages. But about a decade ago, Arkani Hamed and a collaborator found that for a certain idealized theory, you could throw all of that out. No particles, no space, no time in the calculation at all. And instead, just compute the volume of a single, abstract, many-dimensional geometric shape. They called it the amplituhedron, and out the other end fell the exact same answer. The right answer. With no spacetime anywhere in the working. And in 2024, he and his colleague Carolina Figueiredo pushed it further into something nicknamed surfaceology, extending the same trick toward the messier physics of the real world. Now sit with what that implies, locality, and unitarity, the deepest assumptions of spacetime physics. The rules we thought were the floor turn out, in this picture, to not be assumptions at all. They come out as consequences, results, of something deeper and more geometric underneath. The space and time we live in might be like temperature. Temperature is completely real. You can burn your hand on it. But temperature isn't a fundamental ingredient of nature. It's what you get when you zoom out from countless tiny molecules jiggling. There's no temperature atom, and there may be no space-time atom either. Carlo Rovelli has been saying something close to this for years, that time is not fundamental, that it emerges. Sean Carroll, Clifford Johnson, others, a whole quiet chorus converging on the same unsettling note. So the stage itself is a mask. The space in your bones, the time in your heartbeat. Possibly just the surface appearance of something underneath that has no space and no time in it at all.
Every floor we reached turned out to have a trap door, and we are nowhere near the bottom. So let me bring you all the way back to where I started, and to one last image. The oldest mask of all. There's a famous old engraving. You've probably seen it, even if you don't know its name. It shows a medieval pilgrim who has walked to the edge of the world, to the place where the dome of the sky meets the flat earth, and he's pushed his head through the curtain of the heavens, and he's looking out at the machinery beyond, the wheels and fires and clockwork of whatever is really out there, behind the painted sky. And when we look at that engraving, we smile. We feel a little superior. How charming, we think. How quaint. They thought the sky was a dome you could poke your head through. They thought there was an outside and a curtain and machinery. We know better now. Do we? Here's the quiet truth I keep landing on. 1,000 years from now, maybe much less, someone is going to look at our map, our dark matter, our inflation, our expanding space-time, our 4 sigma, our beautiful mathematics. And they are going to feel about us exactly what we feel about that pilgrim. That gentle, pitying smile. How charming. How quaint. They thought space-time was real. We are the pilgrim. We always were. We've just got a better painted curtain. But here's the thing, and this is the strange comfort I want to leave you with, because it is not despair, even though it sounds like it should be. A universe that has no findable edge. A universe that can't be pinned down, that keeps slipping out from under our very best instruments, that changed its own ending while we were sleeping. That is not a universe that's hiding from us. That's not a cosmos playing keep away. It's a universe that includes us so completely that we can never step outside it to look. The reason we can't find the edge is that there's no place to stand that isn't already inside. We are not visitors who wandered in. We are not spectators in the stands. We are made of the same 14 billion-year-old stuff as the galaxies we're trying to measure, and the measuring is the universe doing it to itself. So we were never standing at the edge of the cosmos looking out. We are the place where the cosmos turned around and looked at itself. The masks will keep slipping. We'll paint new ones. And every single time we'll mistake the mask for the face. That's not a failure. That's just what it feels like to be the part of the universe that woke up.